Hello, my name is Shaunik Nag, and today I will be discussing Physics 2212 Lab 1, Charge Tapes. In brief, the lab involved observing the electrostatic interactions between two charged pieces of tape among other objects. The experiment's main findings were the excess charge and number of electrons on the tape of interest. Important physical principles to this experiment were Newton's second law as well as Coulomb's law. I will explain in greater detail the steps of the experiment, the models and assumptions used based on the principles used, and conclude with answering a couple of discussion questions. In order to make things simplified, we are allowed to treat the tapes as point charges with all the charge concentrated at the center. Air resistance is neglected, and we can safely assume the charge is the same between the two tapes as they are created in the same way. Also shown here below is the system, which is tape B enclosed in dashed lines, and its surroundings, which is tape A. In this experiment, I created two charged tapes, tape A and tape B, via friction when each piece of tape was pulled apart from another piece of tape, which in turn transferred charges to the tapes. I observed interactions between the two tapes and between the tape and objects such as my hand, which is neutrally charged, a pen, which is negatively charged, and a notebook, which is neutrally charged. In conclusion, I found that the tape of interest, tape B, is positively charged. Next, I performed the experiment where I put tape A below tape B and brought it close to the point where tape B floated above tape A due to the electric force between the two tapes. As mentioned earlier, Newton's second law is very important to this experiment. As we have seen, the tape will be in a state of equilibrium when B is floated above A. This means that the two forces acting on the tape, the gravitational force and electric force, will balance each other, as shown in the free body diagram on the bottom right. Additionally, the equation for Coulomb's law, or the electric force, is shown on the far right, and Newton's second law is shown to the left. It is also important to note that the charge is a property of matter and it exists everywhere. Shown here are my main results from my experiments. Using the physical principles from the last slide, I was able to calculate the gravitational force of tape B and use the magnitude as the electric force. From this, I was able to calculate a excess charge of about 9.33 times 10 to the negative 9th coulombs on tape B. Next, I had to make some assumptions when calculating the ratio of the number of electrons on tape B to the number of atoms on tape B. This assumption was that the tape was about 1 atom thick, and this was necessary to simplify the calculations. I was able to find the number of electrons on tape B and then the number of atoms in tape B using my assumption to get the ratio. Here I have shown my Glowscript computational model, and the link is also in the description below. Here I have shown something similar to my free body diagram, and here is depicted is tape A on the bottom and tape B, both as point charges. Tape B experiences an electric force and a gravitational force, as denoted by the arrows. I have also included calculations of forces, charge, the number of electrons and atoms on tape B, and the ratio between these two values. To wrap things up, I will talk about a couple of discussion questions. For the first one, if the charges had been switched, the interactions observed would stay the same. There would be no change because like charges would still repel and opposites would still attract. It's important to handle the charge tapes as little as possible because excess charges, given the chance, will escape from the tape. And when something like the hand touches it, the charges will escape to the body. In conclusion, I've learned a few things from this lab. One is that utilizing assumptions allows for modeling of interactions between objects, as shown in the Glowscript model. It makes it much easier to understand. Experimental method is also key, and consistency is also very important. And finally, charge exists in everyday objects. Thank you for watching.